So welcome and thank you so much for joining us today for another installment of the research webinar series hosted by our team here at Michigan Virtual Learning Research Institute, or MVLRI. The goal of MVLRI is to expand Michigan's capacity to support new learning models, engage in active research to inform new policies in online and blended learning, and strengthen the state's infrastructure for sharing best practices. MVLRI is a division of MVU, the Michigan Virtual University, a nonprofit organization whose mission is advancing K-12 education through digital learning, research, innovation, policy, and partnerships. MVU is also the parent company of Michigan Virtual School, a supplemental state-sponsored virtual school, Michigan LearnPort, an online professional development portal for K-12 educators and personnel, and MyBlend, a blended learning initiative providing K-12 schools with resources, products, and services to personalize learning options for their students and improve student achievement. Before we introduce today's presenters and the topic of their presentation, an important disclaimer for our research webinar series. This webinar will be recorded and shared publicly. Consequently, anything shared during this webinar, including chat comments, could be shared publicly. This webinar may represent a presenter's or an attendee's personal views, opinions, conclusions, and other information which do not necessarily reflect those of MVU and/or the Michigan Virtual Learning Research Institute and are not given nor endorsed by MVU or MVLRI unless otherwise specified. So now I'm going to introduce to you two of our presenters today. Shannon Chappell-Moots, our PhD, currently serves as Research Assistant Professor and Assistant Director for Quantitative Analytics in the Center for Educational Partnerships at Old Dominion University. She has substantial experience conducting educational research and has served or is currently serving on over $26 million in funded projects, most of which focus on program evaluation. Her areas of research include educational policy studies, early childhood projects, middle school math initiatives, STEM studies, military child and family educational issues, and projects focusing on college and career readiness. She has collaborated on projects with faculty within the Center for Educational Partnerships at Old Dominion University, and with faculty from Clemson University, Kent State University, Johns Hopkins University, and the University of Minnesota, and with researchers from the Success for All Foundation, the National School Climate Center, the National Institute for School Leadership, and the National Math and Science Initiative. We also have Pamela Arnold, who is an Associate Director for Operations at the Center for Educational Partnerships, a research and development center at Old Dominion University that is focused on education systems innovation at P12 through post-secondary levels. She is a PI on a number of projects, the largest of which is a US DOE I3 award that supports the scale-up of a proven model of middle school mathematics learning facilitated by technological innovations and program redesign. And they are talking today about an examination of an online tutoring program's impact on middle school students' math achievement. So without further ado, I'm going to hand it over to them.
Thank you, Dr. Kennedy. This is Shannon Chappell. As Dr. Kennedy noted, I will be presenting the first half or so of today's presentation. I'll discuss the introduction, a little bit of a literature review, a very brief literature review on tutoring and math tutoring, and then discuss the methods of our study and the quantitative results. And then Pamela Arnold will take over and discuss the qualitative findings and then some discussion and some conclusions, and she'll host the question and answer period at the conclusion of the presentation. First, I would like to say that we encourage anyone that's watching or listening to post questions in the chat box, and we will respond to those directly following Pamela's portion of the presentation. Also, probably should note that I've been battling bronchitis and some other fun infections the last couple of weeks. I'll try not to lose my voice or cough or sneeze or anything terrible, but if I do, please pardon me. So during this presentation, we're going to discuss a study that was published in Online Learning's most recent issue, which was a special issue on online learning in K-12 environments. The complete article is available at Online Learning Consortium's website. PDF versions of the journal and its articles are open source and are available at no charge. And the website is onlinelearningconsortium.org. Our study focused on tutoring that was provided as a Tier 3 support to enhance the overall effectiveness of a school-wide math reform called Power Teaching Math. Power Teaching Math was funded under the U.S. Department of Education's Investing in Innovation Scale-Up Initiative, which is focused on the dissemination of research-based educational programming to high-need schools. Power Teaching Math was developed and is implemented by the Success for All Foundation. So Power Teaching Math is grounded in research on cooperative learning and focuses on teamwork among students within a structured cycle of instruction. There is an extant body of research showing positive achievement effects for the program, particularly among adolescent students. Within a response to intervention framework, Power Teaching Math embeds Tier 1 and Tier 2 supports through professional development and resources that focus on effective instructional strategies, differentiation, strategic grouping of students, and progress monitoring. Online math tutoring was piloted in this context as a Tier 3 intervention for a subset of students who struggled the most with math. The service provider for this study is an online learning and educational technology company that developed a tutoring program designed to provide custom, interactive online tutoring services for K-12 students. Though the company offers tutoring for all core subjects, math tutoring comprises over 70% of their services. Their services consist of synchronous, one-to-one, prescribed tutoring designed to drive student achievement. The provider also administers diagnostic assessments that allow program and school personnel to develop individualized learning objectives for each student who is receiving tutoring. Based on these learning objectives, a learning plan is then created for each student. These learning plans are aligned with the school's curricular standards and scope and sequence to ensure that the services meet the students' and school's specific needs. The custom learning plans serve as the foundation for the tutoring, though the plans are flexible enough to accommodate minor changes over the duration of the program. The tutoring is provided through chat, instant messaging, and virtual whiteboard technology to offer students the help they need to gain a better understanding of concepts and, in turn, help improve achievement. The provider offers a differentiated, engaging environment where skills are enhanced through sharing of curricular materials, practice problems and visuals, and graphic features which aid communication and collaboration between students and tutors. Tutors have a minimum of a 4-year degree and 2 years teaching or tutoring experience. Tutors also undergo background checks to ensure safety even in the online environment, and they are subject to an extensive quality and performance system to provide constructive, effective academic interaction. In-session assessments allow tutors to maintain student progress by skill in a formative manner, and then post-tests allow for an examination of students' overall growth. The literature on tutoring services is extensive and results of tutoring vary widely. However, a review of the literature reveals that many tutoring programs have been successful in improving student outcomes. While there's no specific model of effectiveness, many researchers mostly agree that most successful tutoring programs share some common characteristics, including well-trained, focused tutors providing services, one-to-one tutoring experiences, a structured but flexible prescribed instructional plan, continual assessment to inform instructional efforts, and consistency in receiving tutoring services. Programs that provide structure, a clear link to the school's curriculum, well-qualified and well-trained staff, and opportunities for one-to-one tutoring have shown particular promise, and these should be foundational elements of any tutoring program. Much of the literature on tutoring effectiveness focuses on literacy rather than math. Nonetheless, an analysis of educational outcomes of tutoring found that programs which offered math tutoring revealed the largest effect sizes in improving student achievement. Researchers still have more recently concluded that not enough is known about the effects of tutoring on math scores. This is echoed in the literature on math tutoring, which often does not include details from statistical analyses to indicate significant growth. While some studies have found promising evidence to suggest that interactive online math tutoring may result in learning and achievement benefits for students, less is known about how these programs function as Tier 3 interventions in contexts that carefully structure Tier 1 and Tier 2 supports. And this was the basis for our conceptual framework. So our study explores how online math tutoring impacted student achievement outcomes and perceptions in the context of a wider reform. We addressed the following research questions. How does online math tutoring affect math scores of low-achieving students? What are students' perceptions of online math tutoring services? And how do online math tutors describe their pedagogical practices and student learning? We employed a mixed method approach using quantitative methods to address research question 1 and qualitative methods to answer research questions 2 and 3. We used a quasi-experimental pre-test post-test design to analyze within-group changes in achievement. Additionally, we conducted a causal comparative match sample design to compare tutored students' achievement to that of non-tutored students in one of the 2 participating schools. Model-guided and inductive coding qualitative techniques were used to analyze student perceptions of the program and tutor pedagogical descriptions generated through tutoring logs of each session. Students from 2 middle schools participated in the study. School 1 is a large rural school in southern Virginia, and School 2 is a large rural school in central Kansas. Participants were selected using purposeful sampling. All participants earned below passing scores on their respective states' standardized math assessment or were otherwise struggling math students in the 2012-2013 academic year. About 50 grade 6 students from School 1 and about 70 grade 7 and grade 8 students from School 2 received tutoring during the 2013-2014 academic year. Students began receiving services in October 2013 and attended tutoring twice a week for 20 weeks. Non-tutored students in School 1 received remediation that is provided to all students in core subjects, following the state's tiered response to intervention style format. No additional services were offered to non-tutored students in School 2, with the exception of students who had identified disabilities. An additional 292 grade 6 students in School 1 who did not receive tutoring services but were eligible were included in the between-group analysis for that school. Attendance records indicated that participants in School 1 attended an average of 28 30-minute sessions, with students receiving an average of 14 hours of tutoring each. Participants in School 2 attended an average of 38 37-minute sessions, resulting in an average of 23 hours of services per student. About 60 tutors provided services for each school, with School 1 students working with an average of 6 tutors each, and School 2 students working with an average of 8 tutors each over the duration of the program. The tutoring provider typically administers a pre-diagnostic assessment, one or more formative assessments per skill, and a post-treatment assessment as part of their standard protocol. Initially, we plan to use student scores from these assessments as outcome variables to examine the impact of tutoring on the students' math scores, as well as prior year and current year scores from the state standardized math assessments. However, due to scheduling conflicts, the tutor was unable to conduct post-tests in School 1. They missed a considerable amount of time due to weather, and they were not able to administer those post-tests. Also, in School 2, the state-level standardized assessment was declared invalid for 2013 because it was a norming year. That school had just changed to the Common Core curriculum. So consequently, we used scores from the 2013 and 2014 administrations of the Virginia Standards of Learning, or SOL, as I will refer to it for the rest of the presentation, from the SOL assessment for participating students as pre-test and post-test for School 1, and we used tutor-administered pre-test and post-test for School 2. The service provider also collects responses to open-ended items from students that solicit comments about the tutoring services, and they gather tutor commentary through logs for each tutoring session. These responses were used to explore themes and trends related to student perceptions of the tutoring they received. We conducted paired samples t-tests for each school using pre-treatment and post-treatment scores to determine within-group changes in each school. Tutored students in School 1 were also matched with non-tutored students using a 1-to-2 propensity score matching approach, and between-group differences were examined using an analysis of covariance, or ANCOVA. To address research questions 2 and 3, we analyzed 84 tutor-generated session summaries and 84 post-session commentaries by students across both schools. These data were analyzed using NVivo, a qualitative data analysis software program that enables users to create a flexible node structure where similar data may be coded throughout analysis to assist in the iterative construction of categories and themes. Both model-guided and inductive coding were employed in the analysis. So scores on the program-administered pretests indicated that participating students in each school had below passing averages. School 1 had no students with passing averages on the pretest assessment and no students with passing scaled scores on the 2013 Math SOL. School 2 also had no students with passing averages on the program-administered pretest assessment. At the end of the program, 61% of the School 1 students had passing scaled scores on the Math SOL. Before exposure to the program, the mean score for participating students in School 1 on the 2013 Virginia Math SOL was 383, which is below the proficiency cut score. The average score on the Virginia 2014 SOL math assessment for the same students in School 1 was 406, which is above the 400 cut score for proficiency. So post-tutoring, the group mean exceeded the proficiency cut score. Within group differences for School 1 showed significant improvement with an overall effect of 0.95 for tutored students. At the end of the program, 30% of the tutored students in School 2 had passing averages on the program-administered post-tests. Although the post-test average for School 2 was below the passing level, students in School 2 did show statistically significant improvement in achievement with an overall effect size of 1.47. Both of these within-group effects are substantial, particularly in an educational setting. The ANCOVA for between-group differences on the post-test, the ANCOVA for between-group differences indicated non-significant differences on the post-test between the tutored group and the matched non-tutored group in School 1. However, the tutored group had a higher baseline score than the tutored group. We did control for that, and the non-tutored group's statistically significantly higher baseline score advantage was narrowed post-intervention after controlling for that baseline advantage. It is worth noting that both groups had statistically significant within-group increases in scores from pre-test to post-test, indicating significant growth for both groups. Within-group effect size estimates were 0.95 for tutored students, as I mentioned a moment ago, and 0.24 for non-tutored students, suggesting positive program impacts for power teaching math as well as the tutoring. And Pamela Arnold will take over here.
I'm Pamela Arnold, and I will be discussing the qualitative analysis and our discussion and implication for our findings. So we coded 84 post-session responses from students. These responses were to a very open-ended prompt about what they thought about the session, and response was essentially optional. So we wanted to let you know a little bit about the nature of that data before we discuss the findings with you. We didn't specifically structure items for students to respond to. This was part of the program's typical business to solicit students about their opinions. So most of the positive student commentary was general, which is not surprising given the age of the students and the open-ended nature of the prompt to simply comment on the session. However, even within the unstructured environment, approximately 40% of students spontaneously indicated that they found the session to be helpful for their mathematics learning. About a quarter of those students identify specific learning outcomes of the session, so they were able to identify something specific about mathematics they had learned. For example, one student commented, "Good session, now I understand integers." Another noted, "Now I get irrational numbers and rational numbers." A smaller percentage of students made specific statements indicating that they left the session feeling more confident in the material. So for example, student discourse might include comments like, "Oh, he made it seem so easy because it is," or another example quote is, "It's easy once you learn it." So there were a fewer number of students that articulated explicit affective changes. I'm going to stop myself running. There we go. Okay. We solicited students' suggestions, or rather coded for students' suggestions for improvement to the program based on the more negative commentary that they made in their response logs. So student negative commentary about the tutoring session was far less frequent than the positive commentary, but was often more specific in nature, which also is not surprising, especially if you're familiar with middle school students. They tend to be explicit about what they don't like. So from that analysis, the two most prevalent themes of negative response to the tutoring were related to pacing of the sessions and the desire for more or different types of explanation. So students who made comments about pacing were far more likely to say the session went too slow rather than too fast, which is interesting because the assumption that might be made about students who are struggling is that they need things more slowly or more explicitly. Due to the general nature of much of the commentary, though, it was unclear whether this related primarily to the speed of connection or the actual pedagogical pacing. So there could have been technological interference that also slowed down some of the sessions. However, some students also did specifically articulate on top of that too much time was spent on tutor explanation and not enough on student work. So you see the example quotes up there. The first student says he doesn't let me work out the problem even when he tells me to solve it on my own. So a good number of students were expressing that they wanted to be able to work through the mathematics before receiving an explanation. On the other hand, there were students that also wanted more. So this tutor was great, just needs work on explaining a bit more. We also analyzed 84 tutor summary sessions using model-guided coding for these. So whereas the students' categories were pretty much emic, derived from their words, their discourse, in analyzing the tutoring logs, we imposed a coding schema informed by knowledge of program theory and the related literature. So we actually use schema theory as a lens for looking at the mathematical development of students who struggle, and isolated key features of the program that related specifically to students who may have difficulty abstracting and generalizing math strategies. So from that analysis, the three themes that emerged as most prevalent among the tutors in their discussion of their pedagogy was number one, a focus on ongoing process monitoring, progress monitoring. So a lot of description of the use of pre, post, and in-session assessment data to differentiate their instruction. The second was what we would commonly call in the literature guided practice. So lots of articulation about modeling and practice opportunities provided one-to-one with the students. And the third was opportunities to generate multiple representations and receive multiple explanations. So these relate to both the literature and the conceptual framework used by the program on those three levels. Findings indicated that the tutors provided effective services to participating students, and so we looked at the three forms of data that we have. From the first form, we found that, as Dr. Chappell noted, that over half of previously failing students reached proficiency level in one of the schools, the school for which we actually had standardized assessment data. This implication of that is that individualized online tutoring may be an effective Tier 3 intervention, but we should also know, as Dr. Chappell did, I think, in her discussion, is that these results were observed in a context where the schools were implementing a really well-resourced and proven instructional model that addresses Tier 1 and Tier 2 RTI supports. So I guess the message from that is individualized online tutoring might be an effective Tier 3 intervention, but Tier 1 and Tier 2 contexts probably matter in terms of how effective that Tier 3 intervention is going to be. The second set of data allowed us to see that the tutors described practices that were, number one, had good fidelity of implementation with the model, and those practices also aligned with the literature in working with students who struggle with mathematics. The implication of these findings is that online tutoring programs might consider incorporating specific prompts in each of these areas for tutors to respond to post-session to help ensure that all of those components are systematically addressed in each session. So for example, typically online tutoring logs have very open-ended prompts, or the tutors are just sort of scripting their session. If training online tutors, it might be a good idea to provide some structure to their tutoring logs such that they might get at those things that we know are effective for students who struggle with mathematics, instead of expecting or hoping it to happen organically. And the third set of data led us to the finding that the student perceptual data really suggests that opportunities to master material and receive individualized feedback may build confidence and understanding. So even within the context of that fairly unstructured prompt, some students identify specific learning outcomes of the session. Middle school students typically may not do that. This suggests that online mathematics tutoring that embeds consistent progress monitoring may actually be engaging the students and thinking about their own mathematics learning as a process for enhancing achievement. So in other words, because the tutors are talking so much about what the students have learned and assessing them and talking back to them about it, the students may also be reflecting along with them. The implication of that is that including specific prompts for students to co-reflect on their learning with their online tutors might be useful. For example, online tutoring sessions might conclude with a prompt for students to identify what they learned that session and to explain how they know that they learned this or how they know what they know. The student perceptions of the pacing of online tutoring were mixed, which is possibly a function of the wide variety of reasons student might be assigned to a Tier 3 mathematics intervention. For example, for some students, the achievement gap might have been due to processing issues, and thus those students might require more explanation. While for others, it could have been attention-related issues that might demand a faster pace. So that's worth looking into as a future line of research. Furthermore, the expressed desire on the part of at least some students for more time to work out problems on their own resonates with the literature that describes tutoring effectiveness as a function of knowing how to employ strategic questioning before telling or giving answers to students. Similarly, a number of students express the desire for more autonomy in the online tutoring process, which is something that can inform practice. From the desire to move faster or slower, to work more independently or with more support, and to select a preferred tutor for each session. These ideas are valuable to consider in developing online tutoring platforms, particularly for middle school students who are typically in a location along a developmental trajectory that makes choice and control especially desirable. It's also important to note that the students participating in this study were among the lowest performing students in 2 high-need rural middle schools with large numbers of students living in poverty. These are among the most underrepresented students in advanced STEM studying careers and the least likely to possess the mathematics confidence that motivates and sustains engagement, persistence, and learning in that particular discipline. So, yet, close to half the students indicated that they believed they learned during the tutoring session. A quarter identified specific learning outcomes, and some made detailed comments directly explicitly expressing their own increased confidence in their ability to understand and learn math. These findings suggest that for this particular population of students, the highly individualized and explicit nature of tutoring support may have resulted in affective changes that are related to continued mathematics engagement and further learning. The online nature of the program also made the support available to students in isolated rural communities with comparatively limited access to resources for this type of individualized instruction. So exploration of this theme and the impact of online tutoring programs that embed explicit schema broadening instruction and systematic progress monitoring on students who have not traditionally succeeded with math nor have been well represented in STEM is an area for further research. And now I think we can move on to our discussion. And as Dr. Chappell said before, if there are questions, we'd like to see them in our chat area. So you can simply type in the box down on the bottom. We have some folks typing. Okay, so from Catherine, is there anything that you were really surprised to see in your findings in particular? Something you were truly not expecting at all? I'll go first and then I'll turn it over to Dr. Chappell. For me, I think it was surprising how much students articulated, or at least a subgroup of students articulated, that they wanted more time or more, they wanted to struggle with the problems a little bit more before receiving explanations. That's something that, you might not anticipate students to want to do. The other thing, but it's very good for them. I mean, this is what we want them to develop, that sort of curiosity about mathematics and the confidence to want to try problems rather than having a teacher or someone else tell them what to do. So that was particularly interesting. And the fact that there were a number of students at that age level who were able to articulate specific learning outcomes and specific affective outcomes was also surprising to me. Dr. Chappell, was there anything in the quantitative data that you found that you weren't expecting?
I would say the difference in the I expected maybe a little bit when you look, when we were looking at the attendance and how much tutoring each group received. School 2 received an average of 23 hours of services, where School 1 received an average of 14 hours. I happen to know also, because I was, more closely engaged with School 1, with school visits and things for the, for the overall Power Teaching Math program. So I was in and out of that school 2 or 3 times a year. They missed a substantial amount of time from January to March. They had about a 12-week period where they didn't have a full week of school because of bad weather, ice and snow. And so yet they still had a 0.95 positive 0.95 effect size from tutoring. So I think that was very promising. You would think with School 2 receiving an additional 10 hours almost of tutoring per student, that they would have had a much larger, and their effect size was larger. So I think School 1 has something going on that worked very well. I'm going to go ahead and address Laura Hibbard's question, and she asked, were the sessions offered during the school day from school, or was this an after-school program? This was something that I had in my presentation, and I just didn't mention it. Laura, thank you for asking. The School 1 students were actually pulled out of regular math class twice a week for tutoring, so for them it was a pull-out program. The School 2 students received tutoring twice a week during part of their double block math class, so it was mixed, and again, the schools did what worked for them.
Laura Hibbard had another question about the tutor training. You might want to weigh in on this as well, Dr. Chappell. So she's saying, I think you said a 4-year degree and training in RTI teaching, but not certified teachers, right? And I believe that is correct. And how were these folks recruited? Do you specifically know their recruitment procedures, Dr. Chappell? I think that they are, well, go ahead. Do you have the specific procedures that they used?
I do not know the recruitment. I know they have a 4-year degree and experience either teaching or tutoring. They are not required to be certified teachers, and I do not know what the recruitment criteria are.
And Catherine is asking, as you know, we're often left with more questions to study after a study is over. How true, a lot more often than not. And it sounds like you definitely have that in certain areas from this study that you would like to continue to explore. What are you particularly excited about exploring first in your follow-up studies? Additionally, is there anything that other researchers could do to help your work, and how can they contact you? So, from my perspective, I would be excited in exploring, and this is also a difference in interest and methodology. Dr. Chappell might have some other area of interest, but for me, the students' perceptions were very interesting, and what I think the next line would be is to maybe impose some structure or semi-structured guidance to their responses, so we could really explore those themes of developing math confidence and being able to extract multiple representations and just general schema broadening. It would also be interesting to be able to observe directly in the sessions with the students to see how they are approaching problems and if in fact over time they are developing broader schema, because the data that we did analyze here of course is self-report from tutors and students, so that counts for a lot, but it would be even more interesting to observe what the actual process is. What are you interested in, Dr. Chappell?
Well, I'm going to lean on the quantitative side, not surprisingly. And I've done other tutoring impact studies, and in virtually all of those, we used 18 hours of tutoring as the cut point as to whether a student would or would not be included in the study. And so I would like to explore whether that 18-hour cut point also applies here. It almost seems like it does, just looking at our findings with 14 hours having a 0.95 effect and 23 hours having, an average of 1.47. So that's something that I would like to look at and see if our study is aligned with the literature in that regard.
And the follow-up part of that question was, is there anything other researchers could do to help you work, and how can they contact you? So I believe our contact information is embedded in the PowerPoint, correct?
Yes, it is. My email is in there. Mm-hmm.
And you can also contact us through the Old Dominion University website. We're both listed in the directory there. And as far as other researchers could do to help your work, well, I think I'm always interested in hearing from people that are doing similar types of work or who would like to participate in, upcoming studies, particularly with qualitative research, because it is sort of an endeavor that requires multiple people. So those are two ways. And I think I have seen a new question come in. Laura Hibbert says, okay, I think it would be wonderful to use pre-service teacher candidates to use as the tutor. A plan with this format would allow the teacher candidate to gain experience teaching online, plus also benefit local schools. I think that's very true. I also think that in the process of reflecting, if there were sort of a more guided reflection associated with the tutoring session summaries, that would also be a learning experience for the candidates and a way in which you could align the teacher education instruction with actual school practice. So that's a nice marriage of theory and practice. Shannon, please feel free to weigh in. You have microphone access as you want it.
I think that many of the tutors are current graduate students. I don't have any evidence to support that as a citation, but being familiar with the program, that's the way it seems to me. So, if they're well trained, I would see no hesitation to encouraging pre-service teachers to participate in this kind of program, particularly, like you said, and there were some international differences between the tutors and the students. That's one thing that came out. I think it wasn't a broad theme, but there was some dialect differences in the verbalization. They spelled the word color, C-O-L-O-U-R, so it was, an international difference, and the students were confused. And so I think that if you have students, pre-service students in a community that could share culture and community, I think that could perhaps make a stronger bond. So I think certainly there's a strong argument for that, as Laura and Catherine both have mentioned.
Yeah, that's an interesting question. I mean, I think on the other hand, too, I noticed in some of the discourse that students were looking for tutors like them sometimes. So some female students mentioned that they would have liked to have a quote-unquote girl tutor or whichever it is. And that goes to the autonomy and the ability to select idea behind that. And what we know in teacher preparation and teaching in general is that the workforce is primarily, middle-class white female, at least at certain grade levels. So, I mean, the ability of online tutoring to broaden that for students is also a potential benefit. Let's see. I see another question. You mentioned that there were 6 to 8 tutors per student, Laura asked. Why did you switch up the tutors? Was this a deliberate part of the research design? I think I can speak to that. It was not a deliberate part of the research design. It is current practice in the program. So that was the nature of the data that we received from the program. I suspect that you might be that you have some questions behind that practice. So if you'd like to talk more about that, type us some more.
While she's typing, I'll address that real quickly too. It was more a matter of who was available and quote unquote on duty during the sessions. So it was, if someone's on the schedule from 2 to 4 on a Tuesday and the students are online during that time, that was the tutor that worked with that student. So they weren't necessarily having repeated exposure to the same tutor. And I agree with, her last comment was, if the same tutor was used, more of a relationship could commence and kids would get comfortable with their tutor and might open up a bit more. And I certainly agree with that. Pam, do you want to respond?
I think that's probably true. We know about the nature of relational development and the impact that it has on teaching and learning. So I think that that's definitely a well-taken point. And, on the other hand, I'm thinking that again, listening to the students and remembering back to their discourse, some students were grateful to be able to switch up from time to time. A number of students, they did see the same tutors more than once. So, over those 6 to 8 per tutors, there were more, they had many of them more than one time. So, there were some relationships developed along those lines as well. I think a feature of the program outside of this particular study is that they do after-school tutoring and tutoring on demand. So essentially, when a student needs a tutor night or day that might be signing on, it's not always structured to a particular time in a school setting. So I think that is why they have that somewhat shifting schedule of quote-unquote duty. But I do think you find the same tutors more or less at the same time. And let's see, but since you did switch it up, the results might be more generalizable and less dependent on individual tutor skills. I think that's probably true as well. The common themes that we got out of actually going through all of those tutoring logs and all of those student responses held over time. So that tells us a little bit about it tells us a lot about the fidelity of implementation and the training that tutors appeared to have. They pretty consistently did the same thing. They followed some of the same processes across students, of course, within the context of flexibility and differentiation. But the core structure of progress monitoring, of pre-assessments and post-assessments, of multiple representations, and guided practice and modeling were evident in pretty much every session. Going to take a little pass through our chat room again to see if I missed anything. Laura was looking for citations about published studies in regard to placements for pre-service candidates in blended and online schools. So Catherine says the stuff is happening, but might not be documented as of yet. I haven't seen a lot of publications in that area myself. I think that online schools for pre-service candidates, I think that, one of the challenges for that type of mode of pre-service delivery is having field-based experiences that are scaffolded, in which there is where there is guided practice and there is a knowledgeable other sort of helping the pre-service candidate develop their repertoire. So this particular type of activity allows for that to occur online. Nikki Davis's work from Iowa State. Okay, so we do have one citation. And we have another participant typing, so I'm going to wait for that question to come over. So it looks like Catherine Kennedy is going to be replicating the study from JTE from 2012. So that's a national perspective of what models are out there. At the 2012 study, there were only 1.3%, was that 1.3? Yes, 1.3% of programs doing anything. That's a pretty small percentage. So by anything, you mean anything in terms of online preparation? Field experiences, okay. Field experiences in online and blended K through 12 schools and curriculum. Yeah, so surely as online and blended K through 12 schools become more common, those sorts of teacher preparation experiences are more important. The survey went out to over 1,000 programs. And over 2,500 people in those programs. Mostly field experience coordinators, so they would know. Since we have a relatively small number of people, is it worth it to give mic privileges for this part of the discussion?
Yep, we have about 6 minutes left. Let me go ahead and give Laura mic privileges. Hold on.
Sure. She says, "Oh, I'm fine." Okay. Well, you can still type, but at least you, Catherine, can respond orally instead of typing as much.
Yeah. So we, Leanna Archambault from Arizona State University, and when I was at Georgia Southern University as a faculty member there, we did this study. We started it in 2010 and then published it in 2012, but we did it by ourselves at that time, and then we got smart this year and have brought in 4 other collaborators, including 2 doctoral students at Arizona State University are working with Leanna Archambault, and then also 2 graduate students at Brigham Young University, and they have a big program in preparing teachers in K-12 online and blended learning. So it's a lot easier doing it with a few other people, especially the part that is most painstaking, which is trying to identify those 2,500 people and get their contact information as well as their titles as part of the study. So That's a huge amount of people. And I believe right now, we just presented on this yesterday at the site conference and have about, let me see if we have the numbers here. I think we had 336 total responses so far. And like I said, we have one more reminder to send out and hoping to get over 500 if we can. So usually we get about an extra 100 each time we send out the reminders.
Tutoring is usually the practicum experience or the pre-service teaching experience, right? The pre-service teaching experience or the pre-student teaching experience. So, I would think that tutoring programs would be especially suitable to pre-service teacher preparation programs at a certain point in the developmental trajectory of teachers, too.
Yeah, and it would be, I think, a nice intro for pre-series teachers just to see what they think about and have that opportunity to be an online teacher in a way, especially with that one-on-one. It's really, an intensive, you know, relationship that they're building with the student at that point. So I think it would be a really helpful piece to the field experience and or just an experience for the students to try to test out, as you said, the pre-service
Mm-hmm.
part of it.
Mm-hmm. Yeah, it's interesting. I mean, I know that you're at the point where you're looking to see what the state of the field is essentially in terms of practice. So we really don't know, or we know that not very much is going on out there. But I would suspect for folks thinking about adding that to their teacher prep curriculum, one thing that from our study I see as important is training the tutors. So we definitely would want to make sure that as you're sending pre-service teachers out there to tutor online, that they had a framework, a conceptual framework to work from, and that they were in good contact with clinical supervisors or faculty as they were doing it to be able to, again, have that support for reflecting, because that was really important to the students' learning, I think, was having that consistency of tutoring across time, as well as the N of hours. It almost seems to me that, given what Dr. Chappell was saying before about the N of hours, that it was more the framework of the tutoring that, might have had the impact, and that there is, at a certain point that takes root for students.
Exactly, I totally agree with that. I think we have
Uh,
about 2 more minutes, so if you have any additional questions, please feel free to jump in, but I'm probably going to wrap up in about another minute. So feel free to ask questions. One more question if you'd like.
no more questions, says Laura, but this was really interesting. Thank you. Thank you for posing a lot of really great questions.
Excellent. So yes, thank you so much to Pamela and Shannon for joining us from Old Dominion University. We really appreciate your work in the field, and we hope that you will come back when you have additional things to share with your follow-up studies.
Thank you,
So we
Catherine.
have
Thank you
some
for the
great
opportunity.
opportunities here.
Sorry.
Yes, our pleasure. Totally our pleasure. No worries, no worries. So we have a few opportunities to share your work here at MVLRI. One is our podcast, which is Virtual Viewpoints. If you're interested in being part of a show for that, you would contact Justin Bruno, who's jbruno@mivu.org. We also have a guest blogger program, so if you have anything to share research-wise, you can always be one of our guest bloggers, and the link to that is right on the page. Our next webinar is on March 30th at 2 p.m. next week on job attainment and perceived role differences of cyber school leaders. We'll have Jason Richardson from the University of Kentucky, Dennis Beck from the University of Arkansas, and Jason LaFrance from Florida Southern University. And here's how to get in contact with us. If you have any questions, you know how to find us via Facebook, Twitter, LinkedIn, YouTube. This webinar has been recorded, so all of the recording will be available on our past webinars page, which is that last link right there. And we will also be posting the PowerPoint as well. So Until next time, we thank you again for joining us and hope to see you again soon. Have a great day.
Thank you. Thank you.